Well, hey guys, welcome back to my YouTube channel. So if you're new here, I guess I can't say welcome back, but I do hope you come back. Anyways, I've been sitting here for like 5 hours. Alright, not 5, but maybe 2 hours at most, trying to figure out how this thing works. But I think I figured it out, and I'm gonna show you what I discovered. So I'll be showing you how to derive the equation for the electric field, at an arbitrary point, and let's call that point P, I guess. And that is along the perpendicular bisector, and we can call that, say, PR. Alright, now firstly, I have to tell you that a dipole is a pair of equal and opposite charged poles separated by a distance. Okay, so this is a negative point charge, and this is a positive point charge, and we call the positive Q1 and the negative Q2. Alright, and it's separated by a distance D, and seeing that this is the perpendicular bisector, of course having like a height h, from here to here would be the midpoint, so it would be D over 2, or half times D. Alright, also let's label this R and take a look at the field that will be set up. Okay, let me change the color. Alright, seeing that this is a negative point charge, the field will act towards it, I guess. And it's important to note that negative charged particles or charge points set up a field that goes radially inwards or towards it, like this. And let's say the positive charges have the fields going outwards. Okay? And since we know that, it's easy for us to tell where we'd set this. So it would be going this way. Alright? And let's call that E1 and this E2. Great. There are also angles in this, so let's call that theta 1 and this theta 2. Alright? And it's also important to note that the dipole acts on an axis, okay? So we'll have the y-axis here and the x-axis there, okay? Now the field strength, or the electric field strength at the point P would basically be the resultant of these two vector forces, right? E1 and E2. So that's basically what we'll be going through today. Alright, let me get rid of this because I don't need it. And I am going to need the space, so might as well. Alright, so first of all, let me finish labeling these. So I told you that here an angle is theta 1, this angle is theta 2. This angle we can call, the angles between here, can call theta 3 and theta 4. Alright, so let's start deducing some stuff. Alright, so off the bat, I guess we can say that theta 1 is equal to theta 2. But if you look closely, you'll realize that, say, this is a z angle. So theta 2 is also equal to theta 4. These are alternate angles, so theta 3 is equal to theta 1. And if that's true, that would mean that all of the angles are equal. So theta 1 would be equal to theta 2. which would be equal to theta 3, which will be equal to theta 4. And I guess we can just call all of them theta then, since they're all equal. Okay. Now that we've gotten that out of the way, remember I told you that this here, let's call this EX for now, which is the field strength that we're trying to find at the arbitrary point P. It's equal to the sum of E1 and E2. But seeing that E1 and E2, they both have X or horizontal and vertical components, X and Y components, we'll have to break them into their components. So let's look at the the Y components first. Let's do that first, seeing that they're easier. Alright, so EY would be equal to EY1 plus EY2. Alright, and it is indeed the vertical component of both of these, okay? So the angles are here, and this is where we'll introduce SOHCAHTOA. Alright, we're trying to find the opposite side, so we'll use so sine theta is equal to the opposite side, which we'll call y1 for now, over the hypotenuse, which would be E1 or EY1. Okay? Now y1 would therefore be equal to sine theta times EY1. Alright? And it would be the same really for EY2, except for the fact that the vertical component for EY2 acts opposite or in the opposite direction to EY1. So we'll have to change the sign to negative. So we'll get Y2 being equal to sine theta negative. Oh, I messed that up there. Let's go again. Negative EY2. And seeing that we're supposed to add all this, we can easily put it into the equation and say EY1 sine theta minus EY2 sine theta. Now remember we said the theta is equal to theta, or all thetas were equal to theta because they all had the same value. Then we also deduced that E1 would be equal to E2, because remember, a dipole is a pair of equal, meaning they're equal in magnitude. However, they are opposite in direction. So opposite in direction. And that's, I need to write better. This is a disgrace. Anyways, direction, okay? And seeing that it has both magnitude and direction, it constitutes as a vector quantity. Alright? So seeing that they're equal in magnitude, E1 is definitely equal to E2. That means that EY1 sine theta is equal to EY2 sine theta. So if you subtract them from each other, you'll get 0. Alright? Now let's resolve the x components. And this time we'll use cosine, because cosine theta is equal to the adjacent over the hypotenuse. And let's call the adjacent x1, I guess. Alright, so let's work on that. So cosine theta is equal to the adjacent, which is x1 over the hypotenuse, which is E1 or EX1, and we're trying to find this. So EX1 is, or cosine times cosine theta, is equal to x1, and it would be the same for the component x2. That would be equal to EX2 cosine theta. And seeing that they both act in the direction towards the right, then we don't have to switch any signs. So it would be EX2 cosine theta plus EX1 cosine theta is equal to something. Now, seeing that cosine theta is equal and these are equal as well, the magnitude of E, you would get 2E cosine theta. Alright, that's simple enough. Now, this is where we'll introduce Coulomb's law, and we'll use the equation E is equal to 1 over 4 pi epsilon naught times Q over R squared. And this is the electric field due to a point charge. Okay? And what we'll do is substitute this equation into this equation. Okay? Because we know E. Let me kind of erase some stuff to get a bit more space. So I hope you are following. Probably shouldn't have taken that off, but I'll rewrite the equations. Okay? Could you clean any faster? Come on, get away. Let me use the lasso tool to get rid of that. Alright, I think I'm ready. So the equations that we had were, equation 1 was 2E cosine theta, and the second equation was E is equal to 1 over 4 pi epsilon naught times Q over R squared. Okay. And we said that we're putting this equation into this equation. So what you'd end up getting, let's change the color, is 1 over 4 pi epsilon naught. Let's not change that or trouble it per se. Let's say 2Q cosine theta over R squared. Alright. Now, a few things we need to deduce. What is cosine theta equal to? And what is R squared and R equal to? Okay, first of all, cosine theta, as I said, was equal to the adjacent side over the hypotenuse. And this time we'll be focusing on this entire triangle, okay? Seeing that theta is right here, that would mean that the adjacent side would be right here, which is d over 2. So cosine theta is equal to d over 2, which is the adjacent side, over the hypotenuse, which is this here, which is equal to r. Okay? Also, we need to find out what r is equal to. Alright? R is the hypotenuse, and by Pythagoras' theorem, this side squared plus this side squared is equal to the square of this side. So R would be equal to the square root of h squared plus d squared over 4. Or you could simply write it as h plus d over 2, or you could write it as h squared plus d squared over 4 to the half power. Okay? And these three things mean the same thing. So it's time to start putting this into the equation, right? And let's say 1 over 4 pi epsilon naught, we're not troubling that, times 2q cosine theta is equal to d over 2 all over r, and we will put that over r squared. Now, seeing that d over 2 over r is literally d over 2 times 1 over r, it's the same as d over 2r, so it's okay if we wrote the equation like this as well, times 2q d over 2r times r squared, okay? And that would be, we'll see where the 2 here cancels the 2 here, and we have r squared and r here. Let's clean this page up once again, or not. I think I can move this. Yeah, more space. Great. Alright, let's continue. So we're right here, and we know that r is equal to this right here. Okay, so let's say 1 over 4 pi epsilon naught times qd over r squared, which we found to be h squared plus d squared over 4 multiplied by r, which we found to be h plus d over 2. That is what we have to work with now. Now, going back up here, let's take a look at this. Why disappear? I'm sorry. Okay. H, let's say H is far greater than D. So the distance that separates the charges is way less than the distance at which the electric field strength is felt in this dipole here. Okay, so it's safe to say that D is either less than or equal to 0. Alright, so I hope that was clear. So if D is either equal or less than 0, if you put that into the equation, let's say we substituted that D for 0 and that D for 0, the entire division here would be equal to 0. So we'd be left with simply 1 over 4 pi epsilon naught times qd over h squared times h, and that would actually come to be h cubed. Alright, and also qd is literally what we call the dipole moment. So qd is equal to p, which is the dipole moment. And also 1 over 4 pi epsilon naught is equal to large K, which is the Coulomb charge constant. Alright? So, or the Coulomb force constant. Sorry, so it's the Coulomb force constant. Alright? So at the end of the day, or final equation for EX, which we were trying to find originally, which EX is the, let's use that color, EX is the electric field strength at the arbitrary point P. So I don't like that. That looks funny. That looks nasty. Let's try that again. Okay. EX is equal to KP over H cubed. And that's our final equation. And yeah, we're done. So that's how you derive the electric field the equation for the electric field due to a dipole. I hope it was clear, and if you enjoyed the video and you learned something, feel free to drop a comment and tell me that it helped. I like to see your comments, as well as like, and you know what to do, hit the subscribe button and turn on your post notifications so you know when I post another video. Bye guys.